Hi friends, this is Subrat here, and in this video I am going to discuss about the panel data structure. So let's start. We have already seen there are three types of data structures present inside the Pandas library. First one is the series data structure, second one is the data frame data structure, and third one is the panel data structure. We have already discussed about the series and data frame data structure, and this is the third data structure we are going to discuss. So before that, we need to understand what is a panel data. So I have some slides regarding this to understand what is a panel data. So panel data contains observations on multiple entities where each entity is observed at two or more points in time. And one more point is this is the data model that combines both cross section and time series data. So this is the main 2 points to understand about the panel data. So let me explain you these 2 points with different examples. So at first we'll need to understand what is a cross section data and what is a time series data. So let us first start with cross section data. So cross-section data refers to the data collected by observing many subjects such as individual farms or country region at the same point of time or without regards to difference in time. So what does it means? You have a population of data. In statistic, to get the entire population data, it is difficult, time consuming, and it also costs you a lot of money. So we generally we'll just take a cross section of it. We'll just take a sample from my population data. So in that way we can analyze that sample data and we can use inferential statistic to get some views about my population data. So here this is your entire population, and from that population I am taking one cross section of it. So this is my entire population, and from my population I am just taking a cross section of data. So that's why the name is cross sectional data. So what is the cross sectional data means? You are taking the observation over a single point of time. So here I have persons data and their income, age and sex over only 2018. So only at single point of time, that means at 2018 only I am taking the observations, like Jethalal, Popatlal, Babita, Sundar and Madhvi. All those persons income, age, sex records I am just keeping for the period of 2018. Okay, that is a cross sectional data. So the main characteristic point about the cross sectional data is we have to take the observations over a single point of time without regards to difference in time. So here only 2018, on 2018 year only I have taken those details. I have not taken details with previous year or next year, coming years. Only 2018 details I am just taken. And we have one more data type is time series data. So the characteristics point about the time series data is time series data are the value taken by variable over a period of time such as month, quarter or a year. So time series data occurs wherever the same measurements are recorded on a regular basis. Suppose I want to measure a price of a particular stock, then over period of 2012 to 2018 I am just measuring. So here you are just measuring the variable. So here variable is price. The value of the price I am measuring over a period of time at 2012, 2013, 14, 15, 16, 17, 18. But in case of cross sectional data, we are just measuring all these variables only a single point of time. So this is the difference between time series data and a cross sectional data. So in case of cross sectional data, we are measuring the values over a single point of time. But in case of time series data, we are just measuring the values over a period of time, like this. Here I have mentioned one table 2012 to 2008. So here also you can see the graph from 2012 to 2018. I am just measuring the stock price values. So to understand the panel data, we have to first understand what is a cross sectional data and what is a time series data. Till now we have understood what is a cross sectional and time series data. Let us understand what is then a panel data. So panel data is the combination of cross sectional data and time series data. So let's see how it is the combination of cross sectional data and time series data. And one more point is a panel data contains observations on multiple entities or individuals where each entity is observed at two or more point in time. So here two or more point in time signifying the time series data, and the observation on multiple entities signifying the cross-sectional data. Let us understand this with one example. So here I have one panel set data. So here I am just measuring all these variables like year, income, age, sex of Jethalal and Babita. So here you can see what is here we need to differentiate what is my cross-sectional data and what is my time series data. So here you can see cross-sectional data is measured at a particular point in time. So here at 2016 this record is my cross-sectional record because I have measured it at 2016, and on 2017 also I am measuring all these values for the same person Jethalal only. I am measuring for the period of 2016 to 2018. So this is a time series data because we are measuring over a period of time, and the cross sectional point comes you are measuring for a single year. Here you have measured for the 2016, that's why it is also a cross sectional data. For Babita also I am measuring for the period of 2016 to 2018, that's why it is a time series data. And cross sectional components come because I am measuring these values for the same point of time also at 2016, here also 2016. So the two components present inside the panel data. So here let us see one more example. So here I am measuring the details for three persons here, Jethalal, Babita and Changuram. So Jethalal cross sectional data is 2016 and time series data will be 2016 to 2017. So here two components are present, one is cross sectional component and another one is time series component. For Babita also I have cross sectional component and time series component. Here 2016 to 2018 is my time series component, and the cross sectional components are here I am measuring the values over a single period of time. So 2016 and 2016, these are the cross sectional components present inside my data. So panel data is the combination of cross sectional data and the time series data. So here panel data contains observation on multiple entities. So here multiple entities signifying year, income, age and sex. These are the observation for multiple entities where each entity is observed at two or more point in time. So here see, here each entity is observed. So here for Jethalal this entity is observed for one more period also. So here for Jethalal I am observing this entity values for 2 periods. For Babita I am observing this entity value for 3 periods. So each entity is observed at 2 or more point in time. So here I am observing each entity values 2 or more point in times. So friends, this is all about what is a cross sectional data, what is a time series data and what is a panel data. So friends, let us do some practical examples on panel data structure. We have understood what is a panel data structure, and here we will see how we can create a panel data structure by using Pandas. So before that, let us see some more characteristics points about the panel data structure. So normally panel data structure is less used in data model. We have seen how we can use series and data frame. These tools are mostly used data models in case of Python programming, but panel data structure is lessly used because it is more complex in nature. So a panel is a three-dimensional container of data. We have seen series is a one-dimensional container of data frame is the two-dimensional container of the data, and here in this case panel is the three-dimensional container of the data. So here in case of one-dimensional container we have only one column. In case of two-dimensional container we have both rows and columns, but in case of three-dimensional container we have rows, column and one more dimension called items. Here we can store many number of items with rows and columns. We'll see what is item in future slides. So here in series we can store only one column. In data frame we can store multiple columns or a single table, but in case of panel we can store multiple tables or multiple data frames. So this is the difference between series data frame and panel. Panel is able to store multiple tables or the multiple data frames. Series can only store one column. Data frame can store multiple columns but a single table, but panel can store multiple tables or multiple data frame. So let us see what is the full signature of my panel method. So here, so panel is under my pandas library, that's why I have to import panda pd.panel. Here data, what is the data you want to store? Here the items, how many number of items are there inside your data. So here panel is able to store multiple tables. We can have n number of tables. If you have suppose 6 tables, then items will be 6 here. You have to mention the item names here. So here major axis signifies the row indexes and the minor axis signifies the column names here. So these are the main attributes we can use in case of a panel data. So let us see how we can use this panel method to generate or to get a panel data structure. So we'll see with different examples how we can use this panel method. So let us do that. So before that, I need to import my pandas library and numpy library because I am going to use these two libraries in my code. So as we seen, panel is able to store n number of tables or n number of data frames. Here table is same as the data frame in case of pandas. So at first I need to create one data frame like this. So fruits is a collection of fruits data frame. I have A for apple, B for ball and C for cat. If you print this data frame, you will get like this table. And one more data frame I have, persons data frame. A for Anil, B for Babu, C for Changu. Here the second data frame is the persons. So here I have two data frame. If I want to store this two data frame inside a single variable, then I can call my panel method. Here you can call the panel method and inside that you can pass data equal to fruits and persons. Here item 1 and item 2 is the key. So as we have seen, data can take a n-dimensional array or a dictionary of data frames only. We have to pass dictionary of data frames or a n-dimensional array. So here I have passed a dictionary of data frame. So these are my keys values. Item 1 is my key and item 2 is key, and the fruits and persons are my values. So here items indicating how many number of tables you have. Here I have two number of tables or two number of data frame. That's why I need to give what is the name in string. I need to give. By using this name only I can able to access this fruits or person data frame. So here major axis signify what are the row indexes you have. Here 1 2 3, here also 1 2 3. The row indexes I have is 1 2 3, and what are the column names you have in both the data frame. I have ABC here and ABC, that's why I am giving here ABC. Here for both the data frame, the row indexes and the column names should be same, then only it will work. So here you have created a panel object. So if you are printing it panel pan, so here you can see it is showing you the dimension, how many number of items here. So let me run this one more time. This is my second data frame. Let us run my panel object. So here you are seeing the dimension is two number of items you have here, item 1 and item 2. How many number of major axes? Here you have 3 number of major axes, that means 3 rows you have. How many number of minor axes? That means how many number of columns? 3 number of columns, that's why 2 cross 3 cross 3. So here item axes are item 1 and item 2. Major axis goes from 1 to 3 and minor axis goes from A to C here. So if you are printing the panel object, you will get the dimension, what are the items you have inside the panel and what are the major and minor axes. So now the important part is how we can get the individual data frames or individual tables. So I have to use the syntax like this pan, and within the square brackets I have to pass the item names. Here whatever the item names you have passed here, by using that item names only you can call the individual data frames. So here item 1 is associated with my first data frame and item 2 is associated with my second data frame. By calling those items by the item names I can get the individual data frames. So here one advantage we are getting, within a single variable I am able to store multiple data frame objects. So getting axis name, what are the axis names you have? So index axis, major axis and minor axis. Here we have always 3 axes. So this is the index axis, item 1 or item 2, index axis or the item axis, major axis will be the row axis, minor axis will be the column axis. So let us get only the items. I can use the items keyword to get the items values. So I have only 2 items here, item 1 and item 2, that's why I am getting the values like this. Only get the row names. Suppose I want to get the row names, then I can use the keyword like measure underscore axis, then I'll get the row name. I have 1 2 3 is my row, that's why it's giving me 1 2 3. So let us get the column names here. I have columns called A, B and C. I can use the keyword minor underscore axis to get the column names. So let us print what is the dimension of my panel. As you know, panel is a 3-dimensional data structure, that's why you are getting output as a 3. So getting data types of each items. So these items are of object type, that's why you are getting the output as item 1 as object and item 2 as object. So let us get the shape of my panel. So here you can see shape indicating this value, how many number of items, major axis and minor axis. Shape is 2 cross 3 cross 3. So if you are using the shape keyword also, it will give you the same result, 2 cross 3 cross 3. So here 2 indicating the number of items you have, 3 indicating the number of rows you have and 3 indicating the number of columns you have. So let us see what the size of my panel. So total number of record stored inside the panel objects. I have total 18 number of records. So here you can see I have total of 18 number of records with me. You can multiply 2 cross 3 cross 3, then you will get the number of records as 18. So if you want to check what is the value present inside each data frame, then you can use the values keyword to get. So if you are printing pan.value, this is my first data frame and this is my second data frame. So here you can find out how many number of records you have. Here 9 and here 9. So the count is 18. That's why you're getting the size as 18 here. So by using the values keyword, I can get the individual records inside my each data frame. Let's see some other variant of my panel method. So you can only pass the data. So the major axis, items or minor axis are optional in nature. You can only pass the data which you want to store. So inside the data you have to pass a n-dimensional array or a dictionary of data frames only. So here I am creating a dictionary of data frame, that only I am passing here. So if you are passing only data also, you will get the values like this. So if you are printing pan 2 cross 3 cross 3 ABC 1 2 3, because in case of fruits and persons my column names and row names are same, that's why it is giving me like this table. For the both of the table I have same row name and column names, that's why it is giving me both the tables with the same rows and column values. So you can also get individual items, major and minor axes. Here we are just passing a data, we are not using the major, minor or item attributes. So let us see some other variant of my panel method. So here we have seen the data can take a n-dimensional array. So let us pass an n-dimensional array. So here this is a 3-dimensional array. So here you have 1 2 3 number of square brackets prefixing my array, that's why it is a 3-dimensional array. So let me pass this 3-dimensional array to my panel method. So here data equal to data, this data I am passing here, and how many number of items you have. You want to indicate this item or you want to give some name to this item as item 1. as I have only one number of item, that's why I am giving items equal to 1. So let us print that. So if you are checking the dimension here, I have one number of item, one major axis and 6 minor axis. That means 6 number of columns I have. If you are printing like this, you will get pan of item 1 equal to 0 1 2 3 4 5. These are the your minor axis. These are the column names you have. So if you are only passing the data and with the n dimensional array here, you can mention what is the customized column names you want by using the minor axis attribute also, because here I haven't mentioned any minor axis attributes. By default it is giving me 0 1 2 3 4 5. So let us see some different examples. So here I have used the minor axis attributes and I have given some custom names to my columns here, A B C D E F. So if you are using like this, here you can see if you are printing the pan of item 1, you will get the column names like this, A B C D E F till F. You will get the column names. You can mention what are the customized column names you want and what is the customized row also you can mention. So here in case of major axis I have mentioned row 1, the row name is 1, that's why it is giving me row 1, but in this case it will start at index of 0. By default it will be 0 here. So here you can mention your customized row names and column names also. So let us see some different examples of my panel method. So here what I am doing, so here I am passing an n dimensional array with multiple rows. Here this is my first row, this is my second row, this is my third row. Let's do this. Let's pass this data to my data attribute. So here I am passing this data to my panel method by using the data attribute here, and number of items here is 1. Here I have only one number of item. So what is the major axis you want? As I have 3 number of rows here, you can give row 1, row 2, row 3, and you can see individual columns here I have a count of 6. That's why I have to give 6 number of column names here. So if you are printing the pan object, then you will get I have only one items, I have 3 major axis and 6 minor axis. If you are printing pan of item of 1, you will get like this. Here I have 3 number of rows, row 1, row 2 and row 3, that's why I am getting row 1, row 2, row 3, and number of columns here A B C D E F. And what is the value? 1 2 3 4 5 6. In row 1 1 2 3 4 5 6, row 2 6 7 8 9 10 11 12, here 7 8 9 10 11 12 and 13 14 15 16 17 18. So this is the value we are getting as an output. So let us see with one variant here. So if you are making a dictionary of n dimensional list, as you have seen in documentation, we can pass dictionary of data frames only. So if you are passing dictionary of n dimensional list like this, it will give you an error here. It will not able to take these values. You have to pass dictionary of data frames only, but in this case I am passing the dictionary of n dimensional list here. So here I am getting the error. If you are passing a single n dimensional array, then it will work, but if you are passing dictionary of n dimensional array, it will give you an error. So friends, this is all about the panel data structure. We have seen what is a panel data structure, and we have compared it with series and data frame objects, and we have also seen a lot of examples regarding my panel data structure. I hope this concept is clear. If you guys have any doubt regarding this, you can leave a comment under my video. Thank you.